We are going to solve problem number 11, which is a problem of limits. Our function is limit of x approaching 2 equals square root of 6x minus 4 over x minus 2. The first step is to multiply by the conjugate. You solve and you get 6x plus 4 minus 16 over x minus 2 times square root of 6x plus 4 plus 4. You factor the numerator to cancel with the denominator the x minus 2. Until now, you have limit of x approaching 2 equals 6 over root of 6x plus 4 plus 4. You need to plug in the 2 of the x on the function. Finally, your final answer is limit of x approaching 2 equals 3/4.
Using the graph of the limit function, well, the limit of the f of x, yeah. What that function states is that there is a certain point at which there is either a hole or like the function just stops at a certain value for x. And that's why it's the limit of the function when the value of x is something. And then as it's approaching that value, it can approach from both sides if it is allowed, or it can approach only from the left or from the right without actually touching the number.
In the second problem, we must find the equation of the tangent line given to the function at the indicated point. In this problem, we had to rewrite the function to make it easier to work with. Now that we rewrote the function, we can continue with the problem to find the derivative of the original function. We continue the problem by finding what the slope is, and we can do this by substituting the 2 in the derivative function. Now that we substitute it, we can see that the slope will be 1/2. Then we need to find the y value. We do this by substituting the 2 in the original function. By substituting the 2, we can now see that the y function would be 5/2, and of course, the x value would be 2. To find b in the formula y equals mx plus b, we will need to substitute each of the values in their coordinate place. And now we solve for b. Now since we solved for b, we can see that the b value is 3/2. And now we can finally write the final answer, that being y equals 1/2x plus 3/2.
And then the derivative of x, those functions, the way that you graph those is that, well, the graph shows you like what the slope, well, what you do in those is like you find the tangent line, which is basically like calculating the slope for like each certain point of the graph that you would want. So for those, it's basically like just a lot like a line graph, and then it has like a certain slope and everything, and you have to find it using the formula for the slope, and that slope is according to each point for x that you use. So in a way it's unique because like in between like x equals 1 and x equals 2 there can be a very different slope, and that is why most functions of that type, when you graph them, have the tangent line already